happen in the process of design and production. But this is a house that we totally fabricated in our premises back at IAAC and Fab Lab Barcelona in 2010. So we built a one-to-one house, a solar house in 9 pieces. We transported it into site, we assembled it, and we put it to function. It was able to generate 2 times more the energy that it needed to operate. So not only it was a sustainable house in terms of energy generation, but it was also a sustainable house in terms of local production and process of construction. So the wide range, as we see, of the different projects that we can do in a Fab Lab is very important, because it's the idea that allow us to think that those laboratories, they can contribute to the local production of objects in our cities today, starting from the very small object and reaching to the buildings of our cities. And of course, all this technology and all this shift from the mass production to the personal fabrication is bringing to light many different manufacturing techniques that we, as architects and designers, we are interested to experiment. And those different techniques, manufacturing techniques, they are based on ideas of collaboration, of customization, of distributed design and fabrication, and the mass customization, as I said before. So for example, we are able to start thinking that an installation could be fabricated far beyond physical proximity. So not everybody should be at the same place in order to design and fabricate an installation. That was a project that we did back in 2010. And you see this component, we created an application where each participant, either from Australia or India or Barcelona, they could customize their own piece. They could send it through the internet. We would fabricate it locally, and we would start building a collaborative cloud that was continuously growing. On the right image, you can see the engraved name of each one of the people that they were participating in this collaborative installation. And then, of course, we can customize our design. We can use applications, and we can use this technology in order to customize our own jewelry as we like them and fabricate them locally in order to directly use them. And if we start thinking the construction scale, which is for us architects very important, we can also think that all these technologies, they allow us to start thinking, the previous speaker was speaking about vernacular architecture. So we have tried to use traditional materials, clay material, and combine it with automatization in the production, combine it with control, computer control of the design of these objects, and try to see the limits of the materiality, the limits of the production, and how we can start thinking of this mass customization in 3D printing constructed objects. So these are some simulation of the computer control, and then our robot back in Barcelona creating different kind of structures out of clay. And then I will finish with a project that it is a bit in the similar direction. It's about, pause. Okay, yeah, so a step further from the project that I just showed you is a project that is working with the 3D printing in construction, but based not only on material properties, but also on parameters that they could allow us to start printing in the air. So if we start thinking that the 3D printing technique until now, it really required a layer which was the support layer for the object to be happening, to be formed. This technique is trying to figure out ways of how we can print without any support layer. So how we can start thinking that we could go to areas that there is no infrastructure, or that the environmental conditions are very extreme, as for example in desert. We can brick a robot, we can use the local material, and we can start creating structures. In this project, the material itself it's the structural support of the structure, no? And this we achieve it by controlling 3 parameters. The one parameter is how we mix the material. So the material that you see is a mix of thermostatic polymers. The thermostatic polymers, they have the property to solidify, to cure very quickly. You see the 2 turbines that we have attached to the robot. These are nozzles that they are, on the one hand, giving out material, and on the other hand, they dry and they cure the material that is getting out of the nozzle. So the parameters of how much material is going out of the nozzle, how much mixture, what is the mixture between the 2 polymers, and how quickly, which is the speed of the robot movement, they can allow us to control what kind of structures we can arrange so that when the material goes out of the nozzle, it's being solidified and allow us to create this kind of free-form anti-gravity object modeling. Those are quite experimental, in a way, projects, but the important thing out of all this process, out of this digital fabrication, about the access on the technology and the personal fabrication, is allowing us to think that the revolution in production is happening much faster than many of us think. And if we start thinking, what does this mean for manufacturing, it comes again back to what I was saying. The revolution is a personal one. It's not an industrial one, and it's not a post-industrial one. And it will be happening in our desktops that will be the factory of the futures. And thank you very much.